Good morning, Dr. Rosenblum. Thank you for joining us today, and thank you everyone for joining us as well. My name is Waleed Rahmani, and as part of the Canadian Kidney Discoveries Network, I'm proud to bring the first of what we hope to be many interviews with Canadian leaders in the field of basic science and translational medicine in nephrology. And just a quick introduction to myself. For those who don't know me, I'm a fifth-year nephrology resident at the University of Calgary. I completed a PhD in 2016 in stem cell biology and regenerative medicine, specifically in the skin. And for the last 4 years, I've been working with Dr. Justin Chun, looking at kidney organoids and modeling different developmental diseases, development and diseases using those models. And looking forward, I hope to I'll be beginning a postdoctoral fellowship in Dr. Benjamin Humphrey's lab this coming July. That said, more importantly, with me today is Dr. Norman Rosenblum. Many of you probably already know him. He's a distinguished figure in the field of nephrology. He's a professor of pediatrics, physiology, and laboratory medicine and pathobiology at the University of Toronto. Dr. Rosenblum is a pediatric nephrologist and a senior scientist at SickKids. He has been recognized with a Tier 1 Canada Research Chair in Developmental Nephrology and was appointed as the Scientific Director of the CIHR Institute of Nutrition, Metabolism and Diabetes in 2018, which has been a position renewed in 2022. So thank you, Dr. Rosenblum, for joining us. And agreeing to sit down with us and having this chat. My hope is we can cover a broad range of discussion points, ranging from disease modeling and these novel non-animal models to scientific policy and funding at the federal level.
Great to be with you.
Yeah, thank you for being here. So the first question I have is the Institute of Nutrition, Metabolism and Diabetes most recent strategic research priorities was released in 2021, and I think you were part of that. We're now halfway through the 2021 to 2026 timeline. And as scientific director, can you reflect on some of the successes that you have seen in the last 3 years and what you're really looking forward to in the next 3 years?
Absolutely, Waleed. Thank you. Thanks for the question. As you may know, the strategic plan that was launched in 2021 really focused on nutritional and metabolic health, which is a composite view of the sum total of health and disease-related functions that comprise the playing field of the Institute for Nutrition, Metabolism, and Diabetes, which really integrates what goes in and what goes out. Without being too explicit of what comes out, there's a lot in between. And, a challenge for our institute is really to be able to conceptualize this without having a strategic plan about every different tissue and every different organ and every different hormone, et cetera. And so I think our Institute for Advisory Board really was wise in conceiving of this overarching theme. And we have 4 priorities within that, which really focus on basic mechanisms, translational mechanisms, equity, and capacity. And previous to us publishing this strategic plan, we embarked in 2018, really just as I began my term as scientific director, on the 100th anniversary of the discovery of insulin, which is a key moment in Canadian science and certainly in the history of clinical medicine. And it's a Canadian moment. So we felt it was extremely important to capitalize on that moment, which drew attention from all corners, and to recognize that diabetes and its complications, including nephropathy, are a leading cause of morbidity and mortality in this country, let alone the world. And And even though we have a very strong community, particularly in diabetes research in this country, a great deal more is needed from basic discovery all the way to health service and policy. So we launched the 100 Years of Insulin strategy, which is the largest CIHR investment in diabetes research at a strategic level since the founding of the CIHR. So very significant. Over $84 million, actually about $86 million at this point, rolled out over about a 5-year period. And with numerous components, already 37 new research teams stretching from across this country have been created in very diverse areas of research. So we're very pleased about that. That's been a major accomplishment that we're still building on from a knowledge mobilization perspective. We just published a new funding opportunity for knowledge mobilization to try to facilitate the movement from discovery at whatever level to actual application, which I think is extremely important. We've also, very much in line with our strategic plan, the way it's worded, have just launched a funding opportunity on the juxtaposition of diversity or heterogeneity, if you want to call it that, precision and equity. This is another area that I think is extremely science of the moment. One size does not fit all. That's heterogeneity. Precision is very much the topic of the day, given the kind of scientific tools we have available. And we have to recognize that we need to be equity seeking. And there are communities that have not been part of the progress of science and medicine in as much as we would like. And the tools that we develop, the approaches that we develop, the knowledge that we create needs to cross communities and communities of people that have different susceptibilities for various reasons and different responses to treatment. So these are major scientific areas that we're focused on, very much consistent with our plan. And the final piece that I would mention is capacity building, which you may know has been a major focus for me in my own career in terms of clinician scientist training. But we fully recognize that there's great opportunity to build the communities within INMD with respect to capacity. And we have fully funded 3 health research training platforms that are focused in diabetes and obesity. That's one area. Another area is kidney disease, and the second area is gastroenterology and nutrition. So 3 major new health research training platforms that, of course, the kidney one is well aware. We're very aware of Crescent program, which has been in operation very successfully since the mid-2000s. And has been renewed by this process with full support by the CIHR in collaboration with other partners, of course. So these are our current efforts. As we look ahead, of course, our job is to unleash what I call the brilliance of our investigator community, to facilitate that, and then to act as a convener to try to push discovery through to actual implementation. And that is our preoccupation, is to find ways to do these things and consistent with our strategic plan.
Someone new into the field, I can see a lot of this effort, and I've seen the impact it's had, just some of the research that's been done here in Calgary, and with Crescent as well, with some of the researchers. So it's, thank you for your contributions with that. The next question is really about, accelerating discovery, and I think as clinicians, we often, as clinician scientists, we often struggle with, data or research stalling in the bench and trying to get it into the clinics as soon as possible. And part of that is really the animal models and how their fidelity is really not keeping with human disease. And so the U.S. Congress passed the FDA Modernization Act, reducing requirements on pharmaceutical companies to test therapies on animals before starting clinical trials. And really, this is opening the way for alternative methods such as organoids, organs on a chip, and a different in silico modeling, really to, on an ethical level, to reduce the loss of animal life, but also to save money in the drug development process and accelerate discovery. How do you foresee this policy change really impacting the field of nephrology, not just in the United States, but whether it really bleeds over into cross-border, and just with reference to kidney-related diseases?
Yeah, so this is a very topical area, and I would highlight in our strategic plan, since we were speaking about that, the second component of our plan, which is really about translation and highlights the need for human-based research. So without in any way suggesting that experimental research is not valuable, because I think it is, I think we also need to recognize that the purpose of experimental models in this respect, in terms of translation, is to really help us understand our observations in humans. So we're trying to model humans, not the other way around. That's a key point, I think, because the goal of our research is not to understand mice or rats or zebrafish better, although that's meritorious in its own right, but it's to understand human disease. And so we have to be careful that what we're modeling in experimental systems mimics what we see in humans, which means we have to measure things in humans. And we are at a very important inflection point in science where we can do that better and better. There are all kinds of technologies that can now be adapted or need to be further developed to understand human physiology. And in the kidney world, this a lot can be measured physiologically, but I'll just take one thing that we don't know how to do yet, which is just critical, is measure the number of nephrons that someone is endowed with. So that's an example of a very cutting edge need that we have to understand a lot of things that happen, whether that's developmental or degenerative in disease, the need for biomarkers, etc. So there's a great need for human-based research, but there's also a need for experimental research that allows us to explore mechanistically what is going on that relates to these observations. Now, as you say, there's been a lot of concern, and for very good reason, that some types of animal-based research are not translatable, but some are. So, for example, in some areas like cardiac muscle, they're very translatable, but in other areas, quite disappointing, very disappointing. And so we can't take one brush and paint the whole field with that. But there's a lot of promise in new technology, as you say, chips, organoids, and so on. But let's also recognize that kidney organoids to date mimic the first trimester of human kidney development, which is a pretty early phase of kidney development, and don't even contain all the components of what a kidney really looks like, and not patterned in the same way. So yes, there are opportunities, but there's a need for a lot of continued development to make these models even better. I think people are very aware that, for example, in drug screening, looking at certain kinds of mechanisms, chips, three-dimensional, synthetic systems, printed, organoids, they hold a lot of promise. But in other areas where, for example, far-reaching, like can we make a kidney that would be functional, we have a long way to go. So my attitude is that these are very important innovations in science that deserve further development, really need further development, and have to be carefully, thoughtfully complement existing models that we have available with a clear eye to the fact that we're trying to understand human disease. And if that's our goal, then we have to push the limits on what's useful and what's not useful in terms of doing that. And time will tell, as usual, in science.
Yeah, it's an exciting inflection point, as you put it, as we see these new models come in, and hopefully in the future, so, as time will tell, we'll see if it really those promises bear out.
Perhaps, Waleed, I think one point that I would make that I didn't is,
Sure.
Particularly as I think in the world of nephrology, where the kidney is such an integrative organ, receiving signals and integrating these signals and then providing various kinds of functions. We need models that integrate. And so right now animals really serve that function.
Yeah, that's right. Yeah. I guess that comes to your point earlier, where the cardiac tissue maybe, as nephrologists, we like to boast as our organ is a bit more maybe complex, and so that integration of tissue is more important than as that's a good point.